Okay, here we've got a right-angled triangle, and it's got an angle of 40 degrees in it. So I'm going to work out, use my calculator, what the sine of 40 degrees is. So sine of 40 degrees, let's put that on our calculator. Sine 40, helps you turn your calculator on, sine of 40 degrees equals 0.642787697. We're going to say 0.643, and that's to 3 decimal places. Let's write 3 decimal places. Always good practice to write down what you've rounded a number to. Now, what does that mean? That tells me in this triangle, if you remember sine, SOHCAHTOA, sine is opposite over hypotenuse. So that tells me that in this triangle, the opposite over the hypotenuse is equal to 0.643. And 0.643 is the same as 0.643 divided by 1, because dividing by 1 doesn't change a number. So in this triangle, the opposite could be 0.643 and the hypotenuse could be 1. Okay, so that's what the sine function on our calculator does. Okay, we give it an angle in degrees, and it returns us a number which is the ratio of the lengths of two sides of that triangle, the opposite and the hypotenuse. Okay, so now let's suppose we've got this triangle here. I'll just tape that down. Suppose we've got this triangle here. Okay, so this triangle here, we've got 40 degrees again. We don't know the opposite, but we do know the hypotenuse, and this angle is the same. Now, you'll remember that in a right-angled triangle with a 40-degree angle, this ratio is always the same. So that divided by that is always the same. That divided by that, 0.643. But we can see, so these two triangles are exactly the same, only just one is bigger than the other. It's an enlargement of the first triangle. Okay, now what's it enlarged by? Well, this side is 6, this side is 1, so this triangle has been enlarged by a factor of 6. So that tells us that in this case the opposite x, if the whole triangle has been enlarged by 6, then x is going to be 6 times this number, 0.643. Now, to be more accurate, rather than writing that, I'm going to write that, because I know that that number is exactly right. So, x is equal to 6 times sine of 40, which equals 3.86 to 2 decimal places. Okay, so that's what our sine function is doing. Our sine function is we give it an angle and it returns us a ratio. And when we've got that ratio, and I've done this in a different way how we've done it previously, but we can work out the length of a side. Now, sometimes we don't know the angle. We only know 2 of the sides. So, let's now consider this situation. So let's draw a side there, a side there, and a side there. Okay? And I'm going to measure these. I'm going to say this side along here, if I measure that, is exactly 5 centimetres. And this side here is 5.8 centimetres. Okay. Now, and we want to work out this angle here. I'll call it theta. Now, we know that this side, the adjacent, is 5 centimetres, and this side is the hypotenuse, and that is 5.8 centimetres. Now, we have got the adjacent and the hypotenuse, and that adjacent and hypotenuse, A and H, so car toa, so the cosine is the one that involves the adjacent and the hypotenuse. So cos of our angle, which we don't know what it is equal to 5 divided by 5.8. Now, look here, this is different. We don't know the angle. Previously, when we looked at this, we've known the angle, but we do know the ratio. So the cos function, in the past, we have given it the angle, and it has returned the ratio, adjacent over hypotenuse. But now we want something that if we know the ratio, we can work out the angle. And so what we do here is we use the inverse, which we write with a little -1 up in the air like that. We work out and if you look at your calculator, above the cosine button it says cosine or cos with a little -1 up in the air. Now that function, if you give it the ratio, it returns the angle. So we're going to say theta equals inverse cos of 5 divided by 5.8. And on my natural display calculator, I can type exactly as it is there. So to get inverse cos, I go shift cosine. I'm going to use the fraction button. I'm going to do 5, arrow down, 5.8, arrow to the right, close brackets, equals. And that gives me 30.45031, which to 1 decimal place is 30.5 degrees. And generally we give degrees always to 1 decimal place. So by using the inverse cosine, I can work out an angle. Okay, if I know the ratio, I can work out the angle. As we saw previously, if I know the angle, I can work out the ratio. And I use that angle to ratio. I use the normal trigonometric functions, sine, cos and tan, but to work out the angle, I use the inverse cosine, inverse sine, or inverse tan. Okay?